Thank you for that introduction. I guess I don't need to introduce myself anymore. I am, but maybe my name is Ammar. Thank you all for attending today's seminar. The idea behind this seminar is to myth bust some myths related to mechatronics engineering. I'm a faculty at the mechanical engineering department. So inshallah, I'll try to keep this as brief as possible within half an hour, 40 minutes, so I can leave the floor for questions, which I expect for them to be plenty, actually. So when we're talking about the concept of myth-busting mechatronics for undergraduate and graduate studies, we're looking at the concept of studies, the concept of research. So really, before we even start, let's look at the word mechatronics, how robots actually evolved. If we look at mechatronics, we identify that as a discipline of multiple disciplines. So in this case, if we look at it, if we know mechanical engineering, it's all about mechanical systems. If we add electrical systems to that mechanical engineering, what do we get? We get electromechanical systems. If we add some feedback, some computer control, plus the concept of designing a system. So you have electrical, computer, mechanical, and the control or the design of a system. Then you have mechatronics engineering. So technically, we can divide this into 4 different disciplines. Electrical, mechanical, systems, and computer engineering, all combined together to actually give you the concept of mechatronics engineering. But we also have smart mechatronic systems and intelligent mechatronic systems. And before we move on, by the way, feel free to remember the questions, write them down. I'll try to answer them all by the end. If you think something's critical that I missed, for example, I'll explain what smart versus intelligent is, but if a word is critical, ask me, so you don't lose anything during the seminar. We start by the concept of smart versus intelligent. And again, these are literally some slides from lectures that I give in Introduction to Mechatronics, mechatronic design courses that I teach. So, you know, if you've seen them before, enjoy them again, hopefully. All right, so what's the difference between smart and intelligent system? If we have a smart system, the smart system actually faces a problem and looks for the tools that's given to it, like a smartphone. If you have an app to use, then you can use that app to solve a problem. Now the problem is here, if there's an app, there's a solution. But if the app does not exist, then the solution does not exist. The system gets stumped. Done, it's stopped. So what about an intelligent system? In an intelligent system, if you face a problem, and the solution does not exist, it has the ability to generate a solution, then solves a problem, provide a solution. Also, for an intelligent system, if it faces a problem and there is a solution for it, that solution can be optimized, then used to provide a solution. So, again, now you understand perfectly why we don't call our phones intelligent phones. Because if it faces a problem, it doesn't come up with a solution. It might, at best, maybe propose an app for you to take the decision. And one of the courses that I've also taken is a human-robot interaction. How much authority do you give the robot? It suggests an app, but does it choose an app and solve it without getting your permission? Maybe not. So how much authority each of the human or robot gets? That's a different topic. But today we're going to focus on the basic world around mechatronics. Also, as a quick introduction, I need to identify the concept of a robot. What is a robot to you guys? To roboticists, to me, a robot actually is simply a system that has an input, some control, some brain, and an output. That's a robot. You might imagine, when we talk about robot, you might imagine, something like that. Some crazy, humanoid type of robot. But really, it's a system that takes in some form of input from a sensory system, processes that, and provides an output. Your car is a robot. That drone is a robot. That little cup holder is a robot. The fish thingy back there is a robot as well. I'm going to show you the results. And all the systems here behind me are robots. So really, the concept of robot, we need to simplify that to an input, processing, output, period. Now let's go back to the concept of graduate studies, and this is the main point behind this seminar. What I wanted to teach you is don't be afraid of what's happening after graduation, after you become a bachelor, for an example. What we're looking for here is myth-busting, graduate concepts, before we even myth-bust concepts about mechatronics engineering. Now, is grad school the same as undergraduate school? I'd say absolutely not. In undergraduate school, you have a system. You have courses. You take those courses. You have assignments. You learn in sequence. 1, 2, 3, 4. The courses are designed. The concepts are designed. We actually feed you the information that then you use to apply to solve a problem. But for graduate school, you may find an issue that you never took a course about. How do you research that problem? So you literally learn how to use the tools that you use. We don't even tell you in your graduate school what course you can go back and fall back to actually learn something. That's the important thing. So from in graduate school, you can definitely learn how to use the tools that you have. You're not learning in sequence and given assignments and given tests to learn. It's easy to work during graduate school. It's recommended, it's highly recommended that during graduate school that it's a full-time job. You don't have a full-time job and graduate school. Some students think that, yes, I can work and do my graduate studies. Absolutely you can, but it's not easy. So you can work part-time while work as a graduate student. That's more than fine. Now, grad school could mean bigger paycheck, guarantee for a higher paying job. It's never a guarantee, but it might be a guarantee for a more enjoyable job. I like to be a specialist in that field. It might be less paying than an entrepreneur or somebody who owns a company. So it's never a guarantee for a high-paying job, but I can guarantee you that you're going to love it if you finish your master and PhD in that topic. You're going to love moving forward. And maybe later on, I'm saying it's not a guarantee. I'm not saying it's not a rule. Yeah, you can definitely come up with some patents. You come up with a company, start a company yourself, and become a millionaire. There's no problem. But it's not a guarantee. You can only go to grad school for your undergrad major. So mechanical, I can go only do mechanical type of graduate studies. Absolutely not. You can expand. You can go to the aerospace as a mechanical or electrical or computer engineer. You can always go to mechatronics. Learn something new. Graduate school is a chance for you to learn something new as well. And alhamdulillah, we're getting some faculty, so maybe they can actually provide you some input. Thank you for coming. And myth 5 is only the best students can actually join grad school. I'll be honest with you. I'm speaking in this seminar from my own experience. I'm trying to transfer experience, not just things you can see in YouTube and read in articles. I've seen one of the best outcomes from average to above average students. And I was surprised with the absolute worst outcome from 4.0 students. So don't think that if your grades are not good enough, I'm not going to go into grad studies. It's your own challenge that you need to solve. So really don't get stuck with the fact that only the best get into graduate studies. You should go to grad studies right after undergrad. I would agree with that, but it shouldn't be a rule. You can go out and explore your world. Personally, I worked at different companies. I worked for, during my undergrad, I accumulated more than 2 years of industrial experience. I worked as a researcher and then decided that research is the best for me. That doesn't mean I'm away from industry. Again, I can research for industry, but I mean in the university environment. So there's no time. But here's the fact. Almost 95+% of my friends who say, yeah, I'm going to go work for a few years and then come back to grad school, I never see them. It just happens that way, right? So really, they go out, they develop themselves in the job, they get paid higher, they move up from a team member to a team leader. So sometimes they get married, they have more responsibilities. So sometimes it's difficult for them to jump from that life back to the graduate life. Unless their job requires them to improve themselves, which is, I wouldn't say rare, but, very low percentage that your job will actually send you back to do graduate studies. What else do we have? We have grad school is a debt trap, so you might have more debts. To avoid that, and again, I'm only speaking from experience. I'll take your questions later on. From my experience, I had to work part-time after school, weekends, to pay off my school fees. So I was really happy with the fact that I graduated with 0 debt. That's a big plus. So you can work part-time. You have the chance to work in Uber or Hunger Station or whatever. I have to say, personally, I worked as a taxi cab driver in weekends. and I worked 24 hours in that 2 days a weekend. So yeah, it was difficult, but enjoyable, because when you're sitting in a car, you read articles and stuff, so it did help me. Grad school is the only way to get ahead? Absolutely not. We'll talk about the concept of entrepreneurship in different seminars. You can always develop your own way to move ahead. Grad schools for people in their 20s. I've seen people go back and do grad studies in their 40s. I would say 50s because I don't know how old that guy is, but I can estimate one of my students were in the 40s. You can whatever age, just literally ask for more knowledge, whatever the age is. That's one important thing. If you can't decide what to do, go to grad school. If you can't find a job, go to grad school. That's one of the biggest mistakes I've seen happen to my colleagues. It's like, yeah, I couldn't find a job, let's do masters. And they dragged themselves through masters. It wasn't enjoyable, they didn't like it, they didn't produce good results, and if you don't enjoy something, you're not going to become an expert in that, and you're not going to do a good job. So think of what you like, which will be worth much more than getting paid a higher wage, for example. And one last thing, grad school is meant for an academic career. Now, will a professor reading books all the time? No, absolutely not. I'll show you the research that I did, I'll show you the concepts that I did, and some of the examples that I even showed in seminars to faculty, the ME faculty. So really, it's not just academia. I get a lot of comments saying, I don't want to go to academia. Yeah, I know, but it's not really academia. I don't just read books all the time. So just to give you some types of research, I would say graduate research types. First, you have thesis-based, where you can take courses and do a thesis. And for example, for a master's thesis, for a specific thesis, you can do one contribution, either novel or it's an application. So you take an idea, you apply it to a system, and you prove that you did something, you approve that idea. Or if it's novel, it's a brand new idea that you come up with yourself, and then you apply it. That's usually the measure. For a PhD thesis, it's usually 2 to 3 novel ideas that you apply and to get the outcome for your or you get your degree. For a non-thesis-based program, now it depends from one university or another. I hear KFUPM usually have higher classes, usually 5 to 8 courses. Sometimes you do a project, like the professional masters here at KFUPM. You take about 8, if I'm not mistaken, 10 courses, plus you do a project, which is part of those courses. So, by the way, for a thesis, if you're planning to continue PhD, I'd say again, 90% of the universities out there want you to do a master thesis before you can continue to a PhD. So be careful, you don't fall into the trap of doing a professional master's and then, which means you don't do a thesis, just take courses and want to continue a PhD. You might face difficulties there. Only a limited number of universities accept that. Now for undergraduate studies in the mechatronics, the CX program in the ME department, and thankfully we have Dr. Hawa here with us to correct me because I forgot one point, I just added it, I'm not sure if it's correct. We have 4 courses that you can take in an undergraduate course to become, to have an idea of what mechatronics is and take the CX in mechatronics, which might be offered next year, right, Dr.? Inshallah ta'ala. So you have one course from the EE department, I believe that's an introduction to mechatronics, one course from CIU, which is a controls course, and we have 2 courses from the ME department. We have a robot manipulators type of course, and then we have a mechatronic design course. So if you take those courses, 4 courses, that will be announced, of course, in detail. We're still working on that. But then you can actually attend the CX program, mechatronics program. What I'd like to emphasize, guys, again, that's feedback from you that helped me design this seminar. And in graduate studies, we're not talking about complex systems. We're not talking about, yes, crazy systems that show off your knowledge. It's not really the simple and effective solution is the best. Yes, you can come up with a crazy robot that jumps buildings and stuff, and yeah, fine, but that's not it. I mean, we're looking at simple solutions with a robust idea. When I say a robust idea, is that technically, when I kick that robot, probably it's going to kick me back, but it's not. it's not going to break. So think of solutions that people can rely on. So that's just an idea. Today I'm going to cover 3 different topics, very briefly. That I talked about a lot in the past. 3 different topics to show you the ideas or how simple the ideas need to be, but how effective they should be. So we're going to talk about some active prosthesis, some optimized fuzzy logic training or new artificial intelligence type of training. We're going to also talk about some future research that we have in mind. For the very first topic, we were faced with a problem that we have 300 to 400,000 people with a landmine-related injury. Now, in this specific case, most of them are leg amputation, and this is a very old statistics. I'm pretty sure it's much, much higher now. In this case here, to actually wear a prosthetic leg or prosthetic knee, it usually costs anywhere from 30 to 45,000. Could be higher, could be lower. And in this specific scenario, average salary in Afghanistan in 2019 reached up to 1,000 a year. So imagine how difficult it is to actually, even if in 2021, how high can it be? 1,200, 1,500, 2,000? We're still talking, if it's double, it's 1,000 per year. So in this case, how can we help those people to actually achieve a prosthetic that is within their means? So what if we can design something that's under